Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the next question of paper 2 JEE Advanced Physics paper 2017, that is question number 24. Friends, let us see the next question. The question is a rocket is launched normal to the surface of earth. Suppose this is the earth. It's normal to this. A rocket is launched. Suppose that this is a rocket which is launched from earth. This is earth, surface of the earth, normal to this. So this is the radius and obviously this is the normal. Okay, and this has to move like that. Normal to the surface of the earth, away from sun. Sun is there. Suppose this is the sun. So bigger mass. This is sun. This is standing for earth, and this stands for the sun. The sun. Along the line joining the sun and earth. So along the line joining the sun and the earth. So along this line joining the rocket is launched like that, along this line. The sun is 3×10⁵ times heavier than earth. So that means this S stands for sun, and its mass is how much? The mass of sun is 3×10⁵ times the mass of the earth. Okay, and is at a distance of this times larger than the radius of the earth. That means if RE stands for the radius of the earth, this RE stands for the radius of the earth, then where does the sun lie from with respect to earth? This distance, it says, this distance is at a distance of this times larger than, so this distance D, I call it D, this is 2.5, 10⁴ times the radius of the earth. So this distance is this. Okay. Now, so I'll consider the center to center distance. You can call this distance, but I'll consider center to center distance at a distance of this from the larger than, is at a distance of this times larger than the radius of the earth. This times larger than the radius of the earth. The escape velocity of Earth's gravitational field is only if it is fired from the Earth's surface. If a rocket is fired or launched, then to escape it, we require velocity 11.2 km/s. That is the escape velocity for the object from the surface of the earth. So the VE component is given as 11.2 km/s. The minimum initial velocity Vs required for the rocket to be able to leave the Earth-Sun system, Sun and Earth system. So we have to remove this not only from the gravitational influence of Earth, but also from the gravitational influence of Sun. So both the system, from both its system, this has to leave the system. Now, so the minimum initial velocity, that is talking about the escape velocity for this rocket, for this system or Earth-Sun system, is closest to, ignoring the rotation and revolution of Earth and the presence of any other planet. Only you have to consider these two only. and what velocity you must impart. Velocity or Vs is written as Vs, so how much velocity you must impact so that it will escape. Now the situation is that the concept behind this, to escape any object from any planet, this total energy must be zero. So from these two systems, the total energy whatever it is here, we make it zero. So the basic concept is to find the escape velocity, the total energy should be zero. What is the total energy of the rocket placed on the surface of the earth? Obviously we are considering earth and sun as a system, so not only this rocket has to leave the earth's surface, also it has to leave the um, sun's gravitational field. So the total energy is I'm giving it is half of mv square, that I'm giving it kinetic energy, and the potential energy that the rocket has when it is placed on the surface of the earth is minus g, because the formula for potential energy is minus g mm over r, where this m is the mass of the planet, that is here earth, mass of earth, and m is the mass of the object to be which is placed there, so it's the mass of the rocket. This m stands for the mass of the rocket, divided by r, radius of the earth. It is placed on the surface of the earth, so therefore its radius is re. Minus it will add to the potential energy of the sun. The potential energy will be minus g mass of the sun and the mass of the rocket divided by r. R is the distance, position of that. If I consider this as the sun, then from here to earth, here, this distance is known to me as d, and the rocket is placed here, so I will consider this distance as well. The total distance is re plus d. This is the distance, so I write re plus d, and this total value should be equal to 0. Now this m will cancel out and will become 0. These two to get these two will brought to the other side of the equation. This becomes vs square divided by 2 equals to gme divided by re plus gms divided by re plus d. We must note one more thing, that there is approximation that you can use. This d is much larger than the radius of the earth. This distance is very large compared to the radius. So this d is 4.5. How many times given? 2.4. 2.5 10 raised to 4 times larger than the radius of the earth. So if this distance is very large, then compared to re, so I can neglect re in this expression. I neglect that. It is not 0. It is neglected. It is neglected. So, and vs square divided by 2 becomes, this g I can take common out, and so me mass of earth, radius of earth, plus this g is out, that mass of sun is there. Mass of sun is how many times the mass of is 3 10 raised to 5 times. So 3 10 raised to 5 times the mass of the earth divided by the distance, which is 2.5 times 10 raised to 4, 2.5 10 raised to 4 times the radius of the earth. This neglects this number can be neglected, so this is the expression. Now from here MERE can be taken out, so that is a common factor, so taken out, so this expression becomes V square over 2. This is G already there, MERE comes now, and it is 1 plus 3 times 10 raised to 15 5 divided by 2.5 times 10 raised to 4. This is the value I am getting. You can put it here, you can see this is the expression I am getting. Now this 2.5 is 5 by 2, 5 by 2 is 3 to the 6, 6 by 5, so I'll write this is 1 plus 6 by 5, and this cancels and gives you 1 0, so this is 60, and therefore this becomes GME over RE. This is Vs square divided by 2. This is 12 and this is 1, this is 13, so it is 13 GME over RE, and 2 I can bring this side, this is becomes Vs square. 2 I brought this side, so this is brought toward this side, and this is the situation. Our aim is to find Vs, so Vs is obviously root of 13 and the root of 2 GME over RE. We know that if only the earth is present and the rocket is to be freed from only from the gravitational field of earth, the escape velocity here is 11.2 and in kilometer per second, and that escape velocity is given by 2 gm over r root. That means 2 gm is the mass of the earth and re radius of the earth root. That means this value is 11.2 kilometer per second. If this value is 11.2 kilometer per second, then I'll write this value as here, this is 11.2 kilometer per second, because this is same as this and same as this. This is given in the question that this value is 11.2 kilometer per second. Only Earth's gravitational field escape velocity is 11.2 kilometer per second. So I'll use this as 11.2 kilometer per second. So it's root of 13 into 11.2 kilometer per second. If I take this root of that, I will definitely, I'm getting is around 3.6 times 11.2, which is around 40 point something, you can say 40 kilometer per second. It's nearly that, coming out with that. So a little more than that. So it's not a round figure number, something and coming. So if I see the option, you will see that this is a more correct answer. So it will be 42 kilometer per second. So the option number 2, which is 42 kilometer per second, is the right answer. Otherwise they are getting actually 40 point something. So 42 is the right answer. So this way you have to solve the question. Okay, thank you.